Hello friends, today's question. Two particles A and B are moving on two concentric circles of radius r1 and r2 with equal angular speed omega. At t is equal to 0, their position and direction of motion are shown in the figure. The relative velocity Va minus Vb at t is equal to pi by 2 omega is given by. So these are the two objects, particles A and B. They are moving with the same angular speed but in different directions. Okay, so we are going to find out their relative speeds. So the velocity of the particle B is Vb, and for A it is Va, and it is given that they are moving with same angular speed. You can say angular speed of A and B is omega. Excuse me. It's omega. Okay. So it means the angular displacement of for particle A and B, this will be given as pi upon 2 omega. Therefore, the angle through which they will be rotating within this angular displacement, let us call that as delta t. Therefore, theta, which is your angular displacement, is equal to theta, and for delta t is equal to pi by 2 omega, theta will be equal to omega into delta t. We substitute the value omega into pi by 2 omega, and omega cancels out. So from here we get that their angular displacement theta is equal to pi by 2. So let's draw a new figure based on this angular displacement. So we have, this is our A and this is our B, x-axis, y-axis, and now this will be a particle A and this will be the position of particle B. They have moved, both have moved by the displacement of pi by 2. So this will be VA and this will be our VB. So now we can use the relationship between their angular and a linear velocity, and the inner radii is given as R1 and the outer one is given as R2. So we can say that velocity VA of particle A will be equal to we get VA will be equal to minus, as it is towards negative of x-axis. Okay, so we can say minus omega r1 I omega, and velocity of particle B is our VB, and which is equal to minus omega r2 and I vector. Next is the relative velocity. Relative velocity VAB will be equal to VA minus VB. So we get VAB is equal to minus omega r1 iota minus of minus omega r2I. So from here we can take common as omega I. So we get omega I r2 minus r1. So this is the VAB is equal to omega I unit vector r2 minus r1. This is the relative velocity. This is the relative velocity VA minus VB at t is equal to pi by 2 omega. So this completes the question. Thank you.